What are the three properties of parallelograms that we talked about last week? Start shouting them. Bingo, that's one. Yep. So parallelograms, he said opposite sides are equal. What'd you say? What do you mean cut? Yep, diagonals bisect each other. There's one more. There we go. Yep, opposite angles are equal. Okay. What we're talking about today is we're talking about three specific parallelograms. Okay, what I want you to understand is all three of these are still going to apply. Okay, all these three shapes we're talking about, each are parallelograms. So all of these still apply to everything we're talking about today. So keep that in mind. Okay, we are going to add on little specific properties for each one. Okay, so any questions about these parallelograms right now? Okay, one thing that I want to talk about that I saw on homework a lot that I need to address. Okay, you do not need to write this down. If I have this parallelogram and I have 2x and x plus 3 here, for example, this is what I see a lot of. What is a major red flag right there?
You have to set them equal to each other.
You have to set them equal to each other, but what's the major red flag?
4 sides are equal in age.
Right. Sides have nothing to do with 180 degrees. Okay? Now, if I had this, then would that be true?
Yeah.
Yes, but do sides have anything to do with 180 degrees? Okay? Only angles. So, I don't want to see that anymore. Okay? I see that quite often. Okay? Remember, sides have nothing to do with 180 degrees. No, no. Okay? Keep that in mind. Go ahead and flip to the second page of your notes. We are going to talk about three things. Rhombuses, which is the one you're not really familiar with, and then rectangles and squares. Are you familiar with those two things?
Yeah.
Yes. Okay. So really the only one we're going to focus on majority today is a rhombus. Okay. So looking at these different properties, what I want you to do in the margins of your example 1, write the word rhombus right here. We're going to write the properties. Okay. If you need to know how to spell rhombus, it's right here. Okay. So again, all of these are parallelograms. It tells us that this parallelogram is a rhombus. It wants to know what are the measures of angles 1, 2, 3, and 4. What do you think these angle measures are?
Equal.
What measure? 90. Yep. 90. And what do you think happens with the diagonals? What do we know about diagonals of a parallelogram? They bisect each other. So what is the vocab term I can call these bisectors? They make these diagonals. Bingo. That's one. Okay, so the first property is diagonals are perpendicular bisectors. So again, we are very familiar with what this term means, okay? The diagonals are perpendicular bisectors. Perpendicular means they intersect at 90 degrees. Bisector means what? They split each other in half, okay? Again, are diagonals in parallelograms congruent to each other? Not in all of them, especially in rhombuses, they are not the same, okay? But we do know that they split each other in half. Okay, what else do you notice about this diagram here? What else did they tell us? All sides are congruent. So in rhombuses, you can assume all sides are congruent to each other. That is the big one for rhombuses. Okay, so we know diagonals are perpendicular bisectors, and all sides are congruent in rhombuses. Okay. Is it still true that opposite angles are congruent? Why can we say yes? All sides are equal, and because it's still a parallelogram. Okay, remember all these are parallelograms. We can still assume those three things. Okay. Let's talk about another one. If I look at this right here, okay, they split this rhombus, they tell us it's a rhombus. They split this rhombus up into two triangles with this diagonal down the middle. Okay. What they want us to talk about is the measures of these angles, 1, 2, 3, and 4. Now, why can they assume those two triangles are congruent by side, side, side? It's that shared side, right? So all of these two triangles are congruent by side, 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 which means that we can say angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. What can we call this diagonal right here? What does it do to the angles? Bisector, right? Yep. So that third property under rhombuses is the diagonals are angle bisectors. Okay. What does it mean to be an angle bisector? It splits the angle in half. Okay. So L and J are split in half. If I drew another diagonal from K to M, would those also be split in half?
Yeah.
Yes, because it's a diagonal. Okay, so diagonals are perpendicular bisectors and they are angle bisectors. Okay. These examples, looking at example 1A, okay, also it's going to tell you what kind of shape it is. So here it's a rhombus, so we can assume all the properties that I just gave you. Okay, so it wants to know the length of WY. Do I have enough information to answer WY? Why not? Because some people would say, well, if this is 3, this is 3.
No, because we don't know what the line across is.
Right, are diagonals and rhombuses the same? No, so I cannot assume that. So do I have enough information? No. NA. Now, if I said this was 4, then could I find WY? Okay, if this side's 4, what's this side? Also 4, so the whole thing would be 8. Okay, go ahead and try part B. On part B, remember, always see what it's asking for. Okay, what should you do to make sure you know what angle it's talking about? Draw it out. Okay, it's talking about RPS. So does everyone agree it's this angle in here? Okay, so we are looking for this angle. How can I use what we're given? We're given Q is 70. Okay, how does that help me?
70 is
Why is S also 70? Opposite angles are congruent, because remember, rhombuses are still what? Parallelograms. Yep, rhombuses are still parallelograms. So we know opposite angles are congruent. How can we find X?
subtracted by 180 divided by 2.
Okay, why can we do that?
Because it's a triangle, so it equals 180, and then you need a second angle, so divide by 2.
Right. A lot of you are saying divide by 2. How do I know these two angles are the same?
Angle bisector. Perpendicular bisector.
Say that one more time.
Angle bisector.
Angle bisectors and isosceles triangle. I heard someone say that too. Okay. So I heard we take 180 minus 70. What's that give us? 110. What do I do with 110 if both of these add up to 110? Yep. Take 110 divided by 2, which is 55. So X is 55. If X is 55, what is this side? It's also 55, right? Because what do diagonals do? They're angle bisectors, okay? Similar, if P, both parts of P are 55, what do we know about R? It's the same thing. Yep. Yep. Because we know opposite angles are the same. Okay? Go ahead and try example 2, A and B. Okay, back up here. Once you work with a bunch of these problems, you're gonna notice there's a lot of steps that you can do to get to an answer. Okay, there's no one way that you can get there. Okay, there are multiple different ways. M and O, it's looking for this whole angle right here. Okay, how can we use this 62 to help us? What else can I fill in?
Your N because it's opposite.
Okay, this one right here.
Oh, sorry, no, I meant your up. It's across the one.
Right, what do these diagonals do to the angles? Bisect it. So if this side's 62, what's the other side? Also 62. Okay. What else do we know?
N you could fill in N. It's opposite angle.
Opposite angles are what?
Same.
The same. So what's 62 plus 62? Yep, so this whole thing right here is 124. So what's M? Also 124. Or could I say all of these are both 62? Okay, either way. How can I find the whole angle N now? There's a couple different ways.
180 minus 124.
Why can I do that?
Because all three angles are gonna add to 180 because it like splits it into a triangle.
Right. What do these two angles right here add up to? 180. So I could take 180 minus 124 to give me 56. So that's one way. What's another way? We know two angles. Could you find the third? Yep, so you could have done 62 plus 62, which would just get you to 124. It would be the same thing. See how all this is working out? Okay. Good. So our answer is 56. What if I wanted to know this little angle right here?
Take 62 and minus 180 and divide by 2.
I could, right. Or do I know what angle N is? Right, angle N is what? 56. What do I know these diagonals do to the angles? Split in half. So what could I do? Take 56 divided by 2. Yep. Good. What about B? I want to find QT. That's this line right here.
Oh, you said the 3y minus 1 and 2y plus 3, you said equal to each other.
Why can I say those are equal? So what he said is I'm going to take 3y minus 1 equal to 2y plus 3. Right, because we know by the property all sides are congruent to each other. Good. So if I solve this, so we have y minus 1 equals 3. What do I do from here? Yep. What do you get for y? Y equals 4. A lot of us on our homework went like this. Is that my answer? Right, I got to plug it back in. Which one do I plug it back into? Okay, I'm going to plug it back in for here. So I have 5 times 4, which is 20 minus 4 is 16. A lot of us on our homework went like this. Is that my answer? Right. 16 is this whole thing right here, QS. So how do I find QT? Take 16 divided by 2, which is 8. Yep. So always make sure you are getting what it wants. Okay. Go ahead and flip. I'm not going to spend time on these problems today. We might come back to them tomorrow. I just want to talk about the properties of rectangles and squares. Okay, so on example 3, and these margins are anywhere, just write rectangles and squares. We're going to write the properties just like we did for rhombuses. Okay, we'll start with rectangles. Looking at this diagram that I have up here for you, what do I know, or what does that diagram tell me? What are some properties I know about rectangles?
The opposite sides are equal.
I heard two things. I heard opposite sides are congruent, which is true. Are all sides congruent?
Yes.
Well, not all sides congruent to it, but 2 pairs are congruent.
Right. The opposite sides are, but are all of them the same?
No.
No. Okay. I heard another one. I heard all angles are what? All angles are 90 degrees. That is true. Okay. And then another one with rectangles that's different from rhombuses and parallelograms is that the diagonals are congruent. Okay. This also means they can bisect each other. Okay, diagonals are congruent and they bisect each other. Looking at those diagonals, can I call them angle bisectors in rectangles?
No.
Nope, they are not angle bisectors. Can I call them perpendicular bisectors? Why not? They don't make a 90-degree angle. Yep, so rectangles, they are not angle bisectors or perpendicular bisectors. Okay, so for rectangles, opposite sides are congruent, all angles are 90 degrees, and the diagonals are congruent and bisect each other. Okay, squares. So if I look at this square here, what are some properties of squares? Yep. Yep. All sides are congruent. Be more specific with angles if they're all equal. They all equal what?
90 degrees.
All angles are 90 degrees.
And bisectors are equal.
Yes. We can also say diagonals are equal. Yep. What else do we know about the diagonals? Looking at that image. They are angle bisectors, which is called what? They make a 90 degree and bisect each other. What's that called? They make a 90 degree and bisect each other. Starts with a P. There we go. Yep. Perpendicular bisectors. Are there a lot more properties of squares? Okay. What do you notice about the properties of squares compared to rhombuses and rectangles?
It's a lot of congruent.
It's a lot of equal.
Yeah.
Right. What I'm going to get used to calling squares with you guys is I want you to refer to them as your perfect shape. Okay, because there's a lot of things that are equal. There's angle bisectors, there's perpendicular bisectors. It's all split very equally. Okay. Do you also agree that it has all the same properties as rhombuses?
Yeah.
And it has all the same properties as rectangles? Okay. It has all the same properties as both of those. Okay, so that's why I'm going to call our squares perfect. Okay? What I want you to do, go ahead and try examples 4 through 11. Okay? What you're going to notice, because we haven't gotten to something yet that we will learn in a couple chapters, okay? If there's not enough information, it is okay to put NA to answer, okay? So, when you finish 4 through 11, that's the first thing we're going to do tomorrow is go through those. Okay? So, finish 4 through 11. Once you finish that, you have your IXL assignment. Okay? What do you get the IXL to? 80. Yep.